Alright, let's talk about electrochemistry. Start of a new unit. Electrochemistry involves oxidation reduction reactions that can be brought about by electricity or used to produce electricity. So in your study of chemistry, you know there are many ways to classify different reactions. We can go by type, like synthesis or decomposition or single displacement or double displacement or combustion. We can talk about another way to classify is whether they're exo or endo. Another way we can classify them is, are they organic or inorganic? And this is just another way. In some reactions, electrons are not transferred from one thing to another as the reaction progresses, and in some reactions they are. This second type we call oxidation/reduction reactions, or redox reactions for short, is what most people just call them. Some examples: iron rusting, photosynthesis, metabolism in our body, rechargeable batteries. Inside there is a really good example. When you when you put them into something, the reaction it's an equilibrium reaction and a redox reaction. When you plug them in, it goes this way, making some electrons, and then when you take them out and put them in the charger, it forces the electrons to go backwards and reform. It kind of goes back to this. They can be brought about by electricity, that's when I plug them into the wall, or they can be used to produce electricity, and that's when I'm actually using the battery in something. These redox reactions involve the transfer of electron density from one atom to another. Now this guy, this first reaction here, that's the substance NaCl is ionic. We know in ionic compounds, something is donating electrons and something is stealing electrons. So this one here hopefully would be pretty clear that this is definitely a redox reaction. Electrons are being given up and they're being stolen by this, and I'm making a compound. But this guy right here, this is covalent. Whoops. How is this thing a redox reaction? Because these two reactions, just like it says here, at first glance, they're very different, and they are. It's hard to believe that this guy is a redox reaction, but it is. So let's take a look at that. This example right here, this is actually happening in two steps. The sodium first turns into two sodium ions and gives up 2 electrons, and then those 2 electrons are grabbed by the Cl2 gas, and I get 2 Cl minus. So the one thing seems to be losing electrons, and one thing is gaining them. Now, oxidation refers to the loss of electrons by one reactant. So this is the one where electrons are being lost. Notice they're being made here. Na is losing electrons, so this is oxidation. And reduction refers to the gain of electrons. Notice that Cl2 is grabbing 2 electrons, it's gaining them to form this, so this is reduction. And we would say that Na is oxidized and we would say that Cl2 is reduced. Two ways to remember these changes. There's two little memory aids. Leo says GER, which means loss of electrons is oxidation, gain of electrons is reduction. Or oil rig, oxidation is loss, reduction is gain. So there's two little memory aids there. Pick whichever one you want. I use both, to be honest with you. Next up, these reactions will always occur together. No substance is ever oxidized unless something else is reduced. If something is being oxidized and giving up electrons, we need those electrons to go somewhere. And that's why I need reduction, because reduction would accept those electrons in. So during a redox reaction, some substance must accept the electrons that another one loses. This electron accepting substance is called the oxidizing agent. Okay? So when I look at this example again, we said that this was oxidation and this was reduction. And one way to remember this is that the substance that is oxidized, Na, is the reducing agent, and the substance that is reduced, here it's Cl2, is the oxidizing agent. Yeah. So they go in pairs. This is not a big thing, but in the past I have asked, in a reaction like this, write me the two half reactions, which one's oxidation, which one's reduction, what's the reducing agent, what's the oxidizing agent. Yes. And so here in this example, the reducing agent is Na, and the oxidizing agent is Cl2. So as you saw in this example we just did, redox reactions can be expressed as the sum of two half reactions, so that we can look at those two things separately, what's happening. Each half reaction is balanced for atoms and charge. So notice here the charge on this side of the top reaction, +2, -2. This charge on this side is 0, charge on this side is 0. The charge on this side is 0, the charge on this side is again 0. So I need to balance for atoms 1 and 1 and 1 and 1. So I balance for atoms and charge, and also to the number of electrons in each must be equal. In the top one I have 2, in the bottom one I have 2, and so that in the end, in this example right here, once I decide to add these two together, I would get CD +2, yes. I'm just going to make this a little quicker. I got 2 electrons on the left, I got 2 on the right, so I would get an Fe, CD, 2 plus Fe, arrow, CD, and Fe +2. So I get, this would be my overall reaction, and these would be my two half reactions. So that's our first little look at redox reactions.